Alright, just add a little bit more black Is this black pepper or black powder? Either way. Look at that. Oh, it's delicious. Oh, hey there! As you can see, I'm making myself a delicious chili. Oh, you say you'd like the recipe? Well, stay tuned. Hello, hoppers, and welcome to welcome back to Game Maker Studio. It's been a while since I've done a tutorial in it, but I got really excited about something that I was working on recently, and there's really not that many good tutorials. Actually, there's only really one good tutorial I can think of out there regarding liquid physics in general in Game Maker, and nothing specifically on what I've done. And I thought, well, why not? I'm just gonna make a tutorial on it. So I hope that you enjoy this. If you don't already know how to set up a physics world and stuff like that in Game Maker, go look at my other tutorial. I'm going to assume you know how to do that, but otherwise I'm going to be making this from the ground up in front of you so that I don't overlook anything, and I can think through the process of it again while I'm talking, just so that we can not skip anything. Alright, so the first thing we're going to do is let's go ahead and make two sprites. We're going to have one for the lava itself and one for the walls, I guess, just the collision objects that will keep it contained on the screen for us, and not just going off somewhere. So I tend to call my things when I'm using liquid physics, I just tend to call it drop. I'm going to go ahead and make a new thing for it. I've been kind of weird about mine lately. I've been making mine slightly wonky, only because of the fact that I can perfectly center my origin and everything when it's odd like this. So I'm going to go ahead and make this 33 by 33. It's not going to have to fit into a grid, so it won't matter for really anything else. And I'm going to pick a really, really dark color, and this is going to matter later. So I picked the darkest red right here, and I'm going to go ahead and make it actually even darker. So say OK. I'm going to go to the circle tool, make sure that I'm on this bottom option here, and I have anti-aliasing turned on. Your mileage may vary. This may or may not be a good thing on your system. It seems like it renders slightly differently depending on what computer this is running on, so you may have to experiment with a couple things that I've done here and change them as needed. So anyway, I'm going to go ahead and center this sprite, and then make another sprite for the wall. This one's just going to be, I'm just going to use the standard 32 by 32, just going to fill it in with, let's say, black, because it's going to contrast nicely. It may not look like it now, but it will later, I promise. Okay, so let's go ahead and make our two objects that we actually need. So the first object, just to get it out of the way, let's make the wall. This is going to be the one that's super easy. We're going to give it the right sprite, say it uses physics, give it a box shape and modify it to fit on there correctly, and give it a density of 0, which is in fact infinite density, meaning this wall will never move off the screen, never fall, or anything like that. Okay, cool. Now let's go ahead and make our... I almost said water because I'm so used to calling it this, but I actually like calling these sprinklers. You can call it whatever you want to, but this is the one that will be creating all of and tracking and drawing and doing everything for the liquid for us. So we're gonna have this here. Not uses physics. Doesn't need to have a sprite or be visible, but if it doesn't have a sprite, it won't be visible anyway. I tend to ignore that. And the first thing we're going to add is a create event. Okay, in this create event, sorry for the jump cut there, we are going to drag in a bit of code. So went to the control tab, dragged in execute a piece of code, and it's actually going to be quite a bit that we're going to be typing here. So if you get behind or anything, don't forget that there's a pause button, and you can have an instructor going at exactly the speed that you want him to. Can't make me say other things though, so I guess if I explain something wrong, that's not going to be great. But anyway, we're going to start typing physics particle set radius, and we're going to set it to something actually very small. We're going to set it to 4, which is vastly smaller than the actual radius, which would be 16.5, given the 33 pixel diameter that we gave it, but that's going to matter later on. We're also going to set a max count for these particles so that it doesn't overload our system. I am running on an i7-3820 processor, so it's an X79 processor. It's a pretty good one, and 16 gigabytes of RAM. Not the best RAM, but it's still, 16 gigabytes, and two 560 Ti graphics cards right now. So just in case you have lesser performance than I am, I have tried to optimize this a bit. This was running on Celeron earlier today, but not quite with as many details plugged into it. So if it slows down, you may have to disable some of the stuff that we're typing here, but other than that, it should work pretty well. So here we're going to say we're actually let's see if I can space this out a little bit better. A physics particle flag is just basically a classification for what type of liquid we're using. And what's cool about it is you can actually use what's cool about it is you can actually stack them. You can have more than one classification for the same liquid, which makes it kind of interesting. When you combine them, you get some very interesting effects, and actually this part is the most crucial part in making the lava act like I had it acting at the beginning of the video. So physics particle flag tensile, and a third one, physics particle flag viscous. Alright, I'm going to go down an extra row and type a little bit more. We're going to go ahead and say physics particle group begin. So we're defining a group, and we're going to define the group as having these flags. No group flags though. It's going to be X, Y, 0, 0, 0. What we're doing here is defining all of the components of this physics particle group, because what we're about to do is create all of the lava at once, rather than have it trickle in from a sprinkler as we've named this object, but we will add something later so that it will respawn any drops that happen to fall, completely off screen or something and get destroyed. So what it's doing here, though, is it's going to create a giant block of lava, and with this block of lava, it's going to have certain attributes. It's going to put the center of it at X, Y, so wherever we have this sprinkler is where it's going to be centered at, and it's going to be at an angle of 0 with no X velocity or Y velocity. You can see them all getting selected down here. No angular velocity. The color overall is going to be white. Alright. The alpha is just going to be 1. The strength will be 1. And the category will be 1. Alright. And then on top of that, we need to tell it a box to actually create all of this in. So we're going to say physics particle group box. This one's kind of hard to define. It's really strange. So we've already said the center is at XY. We need to tell it half of the width and half of the height from that center, and then so it's basically the radius of the box. It's very odd. So I'm just going to say 160 by 160, which is actually more than big enough to encapsulate this many particles with a radius of 4, but it's giving us a little bit of leeway as well. Ooh, had a bit of a coughing spell there. Anyway, one thing more that I've added here, which is the very end of our create event, is physics particle group end. So we're just ending the group now that it's created this box for us. So go ahead and click check on that. And let's add another event. We're going to add a step event that won't probably ever do anything for us here, but I'm going to add it just as like a failsafe if we start leaking lava somewhere. So we're going to go ahead and say physics particle create flags. So remember, flags is what we just used to define what qualities this liquid is going to have. And then instead of just having it come out at 0, 0 for velocity, we're going to give it a little bit of random velocity so it doesn't come out in perfectly vertical lines, which honestly looks a little bit strange. So I'm going to say 5 minus random 10, which means it's going to start with 5 and then subtract a random number between 0 and 10, giving it a range of -5 to 5 for x velocity, and we're going to type the same thing for y, so 5 minus random 10. See white for the color, alpha will be 1, and category will be 1. Alright. We'll probably add a destruction box as well later, just to get rid of anything that goes off screen. For now, that's just going to sit there and be an alternative to, oops, sorry about that, be an alternative to this part right here. So these connect independently of each other or can supplement each other, whichever way you prefer. But for now, we're going to move on to our next event, which is the draw event, and the real like behemoth of all this. This is where the money's made and everything. So I'm going to make this as big as I can. I think that my last version had about 64 lines of code in it or something. I can actually look over and check real fast. Yeah, it was exactly, nope, 65 lines of code. Oh, but with one blank one in the middle. All right. So while you can literally type one line of code to get the drops to display, it won't look that great, and it can be monochromatic, which if you're going for a certain field, that can be great. But what we want to do here is not only have the drops change color as they move at different speeds, we also want them to glow as they compress into each other, and we also want them to kind of stretch and skew as they move through the air. And having all of that happen is what those extra 64 lines of code are. So the first thing we're going to say is var count equals physics particle. My goodness, if I could type better today, I would be so happy. All right. So we're defining a variable named count, and it's checking the system to see how many particles are actually out in the room right at this moment. So the next thing we're going to define is var data flags. So this is another set of flags that we're defining here. These flags, what they're going to do is actually store the position and velocity of every particle for us as that particle comes up in the little queue of this draw event. So we're going to say fi underscore particle, and it's already showing up for me here. We're going to say fi particle data flag position, as well as fi particle data flag velocity. All right. And then we can end this line. I'm putting a semicolon on every line. GML doesn't really care usually if you have a semicolon or not, but I have run into circumstances where it did matter, and it's generally just best practice to end your lines with a semicolon just in general. So I'm certainly going to keep doing it. I recommend you do too. You could end up with some strange errors otherwise, and honestly, if you're ever going to program in any other language, you'll need to have that habit anyway. So what I'm going to do here is define one more variable, and this one will actually be needed later, just so that we don't have to fiddle with this so much. So I'm going to put a comment here that you don't necessarily need to put, but if you need to remember what this one is actually the color threshold limit. I hope I spelled threshold right, because that's a weird word. And what I'm going to say is that lower numbers are for more yellow, sorry, and higher numbers are for more red. This is just if you need to come back and edit this later, to have the glow of the center of the lava be a bit more red or a bit more yellow. It'll be very easy to figure out what part you need to change. All right, the next thing we're going to do is set our draw mode to normal. Blend mode BM, no jokes about that. Normal. My BMs are normal. Just think about it for a second. Anyway, then is going to start the big bulk of what we need to do. So this was all getting prepared up here. I'm going to put a line down because the next part is a little bit separate. So what we're going to say is if count is greater than 0, then we're going to start our main section here. So we're going to say var buffer. We're defining it. Yeah, but that's right. Buffer. And we're going to make a new buffer just so that we can actually store this information temporarily of the particles information. Count. And we're going to make it a bit bigger than it needs to be, just for safety's sake. Buffer. Grow. 4. Alright. Now that we've set up a buffer, we're going to start loading the data of each particle into it. And we're going to say physics particle, get data. We're going to put it in our buffer. And it's going to be the particles with data flags. And as you can see at the bottom, we're actually using the exact same words that are in the guide that's telling us what type of information we need to have in there. So it kind of helps to have the exact same names as what it would suggest anyway. So now, after we've loaded all of this in, we're going to start a for loop. And this for loop is what's actually going to be doing really all of everything for us. So we're defining a new variable here of var n equals 0. Just go ahead and copy this road. If you don't know what a for loop is, I wouldn't change anything about it because there's really no reason to, honestly. In ++. All right. Define lots of new variables here. Var xx is equal to buffer read buffer buffer f32. So you need to copy this part exactly. Actually, now you need to copy this part exactly. And what I'm going to do, because there's going to be a lot of repetition here for the next 3 lines, is I'm just going to copy this line here and paste it. And I recommend you do the same because we're only going to be changing 2 letters on each line, or just a couple letters on each line. So 4. All right. So this next one, you can probably guess, will be YY. All right. The next one after that will be xval, and you can say a different name here, but do remember that these will be read in order, so you make sure that you have x, y, x vel x velocity and then y velocity. If you want to call it by its whole name or something like that, pretend that's spelled correctly, then you're welcome to, I guess, but make sure that they are in this order, or just otherwise have them exactly the way I do, because I will be using them later. Obviously, I wouldn't just define them for no reason. Now we're going to do a little bit of trigonometry. We're going to say var vres, so resultant vector, is equal to square root, so squirt, absolute value. This is actually from a bit of trial and error. I always tend to get this a little bit wrong if I don't have my own guide to guide me here, because it's something with oh, accidentally deleted something. It's something with I keep wanting to say val, don't I? That's really strange. Yeah, it's just something with the way that GameMaker handles the math sometimes. Let's see, x velocity squared plus y velocity squared. Where's my caret? There it is. And we're going to define another variable for later that is going to be the exact same number as the resultant vector, just because we will probably end up changing the resultant vector's number after doing something else. So we want this thing, which is velocity color, which will make sense later, before we end up changing the resultant to some other contrived number. So now I'm going to say var dir for direction is equal to -1 times rad to deg. So here's the trigonometry, really, converting. So we're if you don't know, rad to deg is the shorthand for converting radians to degrees in GML. arc tan 2 y velocity x velocity plus 90. Alright, that's a lot of our variables taken care of. Now we need to do a couple more things. So we're going to say if the resultant vector has a higher number, is higher than heat, which, if you recall, we defined up here, then we're going to just say vcol, then we're just going to say that vcol equals heat. Alright? Otherwise, we just want it to stay what VRES is up here. So it's just instead of having an if-else statement where we just defined it, and then if we need to redefine it, we're doing it here. Alright, now after that, we're going to say that call equals make color, because GameMaker was originally made by Mark Overmars, who is a British friend of ours. 255. So if you're unfamiliar with the way colors work in computers, it's red, green, blue. I know that I'm picking strange things to explain, but we're defining the maximum value for red because we want it to either be red or yellow or somewhere in between. And the way you get yellow is by mixing red and green at equal values. So when we have the most amount of green in here, it will have transitioned all the way from red to yellow, all the way straight through orange. And the way we're going to have it transition is actually just by saying vcol divided by heat times, now I'm not going to say 255 because of the way this will render later. I'm actually going to say times 240 plus 15, just to give it a little bit of wiggle room in there, and so that the colors will be able to add on top of each other more correctly, and it'll just look nicer, because when you have a little bit of the yellow or when you have a little bit of the green channel in there and you're using an additive blend mode, it helps out a lot. Rather than just having one channel, it maxes out almost instantly and then just can't do anything interesting looking. So we need to have at least a little bit of other color in there just to make it look nicer. Alright, the next bit will be if VRES is greater than or equal to 8, so a speed of 8, then we want... So what I'm going to do here, I've realized that we forgot to add one more thing. We do need one more sprite. I don't usually use 2 sprites for drops, but for this, for lava, we need it to be very opaque, not just transparent. And because of that, we'll have to go back and add one more sprite before this actually works correctly. So you will have an error on this line just for a few moments until we go back and change it a little bit. So we're going to say draw sprite, ext. Rather than doing the particle itself, we're actually going to be drawing a sprite on its place, and it's going to be SPR drop, drop, oh my goodness, drop back, so it's going to be the back half of the drop, 0 XX YY. And then we're going to tell it a couple things for the scale. So we want it to be smooshed out. And what we're going to do is actually say 1 divided by VRES over 8. And then we're going to say that the Y scale of it will be 0.75 plus 0.25. I know this is weird. I fiddled with this so much to make it not look, goofy. These are the numbers I ended up with. Feel free to change it as much as you want, for sure. But this is where I felt it worked well. So divided by 8 right here. Then we're gonna have it turn the correct direction. So dir. That's why. Just sounds goofy. So that's why we defined that earlier. And then we're gonna make it be the color that we just defined as well. And it's going to just have an alpha of 1. Alright? And then after this, we need to basically say the same thing, but with less involved. So if it's not quite going 8, moving at a speed of 8, we're just going to have it be the full circular blob. Alright? And to do that, we're going to say else. And inside these brackets, we're going to basically be typing the same thing. It's going to be draw sprite ext. Oops. And this one's going to be SPR drop back again. So I'm so worried I'm going to forget to go back and do that. And the difference is that its scale is just going to be 1 to 1. So this is actually much easier to type. We just say 1 1. Then we just say direction color. Oops. And an alpha of 1. Alright, so we're actually getting pretty close to having this working totally correctly, which is awesome, because I did not expect to be able to go through this quickly, especially with talking as slowly as I am today. I should have definitely waited till I felt better, but I was just too excited about figuring this out finally. It's pretty sad. Anyway, we're gonna then delete this buffer. And in that there. So what we need to do now, we've only done the back part of it. We haven't actually done what will display it in a really cool way and give it that glow that I really like. So this actually may work on its own as long as this has the correct sprite on it. It won't be glowing, it won't be the right color though or anything, in my mind at least. So I want to add a little bit more to this just to make it super nice. Oops, gotta add that last curly brace there. Alright, so what I'm going to do, I know it seems a little redundant, but instead of nesting this for loop inside of this if statement, I'm going to have this entire part copied down here. Just because it seemed to work better on my machine to have it that way rather than having 2 for loops for this buffer inside of the same if statement. I'm not sure why, but maybe it's just my system. So go ahead if you want, try putting this for loop directly in after this for loop ends before we delete that buffer. It may end up being more efficient. I'll let you tell me if it worked out better for you that way. Anyway, we need this one to be mostly the same as the previous one. You can see where we got most of those 64, 65 lines from. And what we want to change now is actually just a couple things. We need to go down here and get rid of this back. And we also need to add some other nice stuff just to make it a little bit more, I don't know, pop. So now that we're in here, we're going to actually... Again, I've fiddled around with this a lot. It tends to act differently on every system. The way that I've found that was making this work most reliably, at least, don't ask me for the logic in it, but I'm going to just change the blend mode inside of this for loop rather than outside of it. It just seemed to work better. Again, test it on your own, see if putting this outside or something will work better. I just found that it works better here. So we're going to say draw set blend mode BM add. This is what's going to do that great glow for us. And then we're going to, we've already changed these two to drop away from drop back. That should be just about everything that we need to add here. We do need to add another line down at the bottom that actually says draw, oops. That actually says draw set blend mode normal, just to reset it from inside of that for loop a minute ago. And after those few changes, it actually is pretty much ready. We need to just make a few last minute adjustments here. I'm going to go ahead and set my depth of my sprinkler to be 10, just something lower than the wall, which is at 0. Remember, 0 is the highest, unless you go into the negatives. So I've set that to 10 now. We're going to make a new sprite and make it SPR. Make sure you spell this exactly the same way as before, as I'm sure you know. Drop back, and it's going to be the same, same size as the other one. This time, instead of what we used before, we're going to go in here, make sure it's anti-alias, and it's just going to be exactly the same shape, size, white circle. Say OK on that. Check. Make sure it's centered, and click OK. And now all we have to really do, I think that's everything, is go ahead and make our room. So let's create a room. And there's something really big here that you'll need to do. So if you're not confident that your computer can run the game at 60 frames per second, 60 full steps, and updates to the physics engine for every single particle per second. Set this to 30, but then set this number to match it. There seems to be a odd bug. I'm not sure why. That works best when the gravity is set to about the same number as the room speed. It's probably a coincidence more than anything, but when the gravity is set to a y of 60 with pixels with the default pixels to meters conversion, and the speed is set to match that, it one of the aspects of the liquid that we made goes a bit nuts. Now it will anyway in higher gravity settings, but it seems to do it the most spectacularly in this setting. So there is an issue that I hope they never fix, because I really love it, with one of the things that we did here. So if we had just called this water or something, it would just look like water. But the fact that we added this one thing, tensile, it's really the surface tension is what this is for. It works great till a point, until there is just too much water compressing it down, like it's reached too high of a pressure at the bottom of a puddle that you've made, or a little pool or something, or if the gravity is pulling it down too much, it hits this breaking point where it just can't anymore, and basically it just starts acting nuts, just acting up like crazy. So what I just did was I pushed play on the game, even though I have a totally empty room, because I got excited. So let's go ahead, and I'm going to put in as many wall objects as I need. So I'm going to hold Control and Shift to draw them in quickly, and I'm going to put them all the way around the outside of the room, instead of putting them on the inside, just so that we can not have to deal with them out there. I've got my game settings, or I've got my game maker settings set up so that it won't bug me about that generally. And then I think what I told it was that we'd have a square radius, which doesn't make sense, but our square's radius, our block's radius, whatever, of creation for that group of particles was 160 by 160 right here. So what I'm going to do, that's on a 32 by 32 grid, that's actually going to be 5 grid squares in every direction. So I'm going to set up some walls like you saw at the beginning. 1, 2, 3, 4, 5, and this is where the center is going to be, and 1, 2, 3, 4, 5. So this is where the other set will be, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the top of the square could potentially be up there, but I'm pretty sure that our limits will be a bit behind that anyway. We don't have enough particles to fill this whole thing up anyway. So it looks like I've made a mistake, just judging by what my eyes are telling me here without even counting them. I'm pretty sure this needs to be there. All right, now we just need to add one little sprinkler thing right in the center. And that should be enough to get this going. Because of the way we set it up with the backing for this, it doesn't matter what background you have, so I should be able to put any sort of background on this picture. If we go with the cool blue, it actually probably look really cool. I haven't even tried it with the blue yet. So let's test this together. Let's see what it looks like. Whoops, looks like I put a typo in mine. Hopefully you didn't make the same mistake I did, but I made one little mistake way down here. Instead of saying BM normal, I said normal on accident. I didn't catch that it didn't light up red. Hopefully you don't have too many typos in yours, but I think I left it on screen long enough for you to be able to pause and spell check with everything. Oh, very interesting. Okay, so after several minutes of searching through everything, I realized what my problem was with the display of this one versus this one. You can see a pretty significant difference there. When it splashes down, it looks really bizarre, and that's because going against my own advice halfway through the video, I didn't make the color quite right either. So I said make it a dark red, but instead it should be actually somewhere in the middle of a very dark half saturated orange, somewhere around there. That's what I was using. If you want to use the exact same numbers as me, it's 50, 39, 14 from the one in the example. So I'm going to go ahead and do that. This is actually from the other game right now that I have open. So I'll go ahead and open this one and set that, and let's see if this ends up working a little bit better. So I'm going to go ahead and erase this guy. And let's change the color. It's going to be 50, 39, 14. And let's draw this sucker back in and see if this works a little bit better. I'm hoping it will. I'm certain it will, actually, because I actually even copy and pasted my code from a different game I'm working on into this one, and it performed the exact same way with the exact same problem, which told me it was the sprite that was the issue. So this should work. Sorry for that slight misleading you there, but otherwise, there it goes. Oh, so much better. Look how pretty that is. And let's go ahead and test that with another background color just to be certain. But I am already honestly quite certain that it will work. So let's go with the blue, since that seems... This will actually look a little bit strange. It might hurt your eyes a little bit because it is a very similar value and saturation to the other colors being used, but it should show up exactly the same. Excellent. Look at that. So any background it's in front of now, it should look about right. There's definitely some tweaking I would do to this one too, as there would be with anything like this, just to get it exactly the way you want it. But anyway, I hope you enjoyed this video, Hoppers. I know it was a long one and kind of a very boring and dry one, but I was so excited about this, and there are just vanishingly few video tutorials out there that I can find, at least, about a Game Maker Studio and how to use liquid physics in it. So in any case, if you enjoyed it or not, well, I really do hope you enjoyed it, but I hope you found it helpful in any case, and I'll see you next time. Hasta Ventana.
Boom 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 boom